So let's just pretend that there are 26 total people in our class, and this is the breakdown I'm going to give for the number of siblings people have. So we'll say 2 out of 26 have one sibling, 6 out of 26 have two siblings, 7 out of 26 have 3, 5 out of 26 have 4, 4 out of 26 have 5, and 2 out of 26 have 6 or more. So the first question asks, is this a valid probability model? The reason that you should recognize back from chapter 5 why this is a valid probability model is because all of your probabilities add up to 1. And all our numbers between 0 and 1. So our next question asks, is 5.7167 a possible value for x? And the answer to that is no. Why? Because we can't have 5.7167 of a sibling. So you can't have part of a sibling. And this gives way to the fact, or one of the things we'll be talking about, the fact that we're dealing with discrete variables in this lesson, which means like you can't have a fraction of something. They're going to be whole numbers. You can't hit somewhere in between. So our next step here is to make a histogram to display this data. So really quickly, I'm going to draw out this histogram. You should draw yours along with me. And I'm going to label, make sure you always have labels. Hopefully my pen skills will get better as time goes on. So this would be 1, 2, 3, 4, 5, 6. And that is, that would be number of children, or number of siblings. And if we were to do the other axis, which would be the probability out of 26 in getting those values. So let's go back and label that as well. So we have 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. This is the probability out of 26 of getting those values. So remember, histograms touch. So we're going to take the first one, and we always put it in the bin above. So 2 out of 26, and then 2 siblings would be 3. Oh, I'm sorry. That's actually supposed to be 6 out of 26. So we'll draw that all the way up to 6. And then 3 was 7 out of 26. And 4 was 5 out of 26. 5 was only 4 out of 26, and 6 was 2 out of 26. And this question asks, make sure you display the information and describe its shape. So this is maybe a little skewed. To the right. And it peaks at about 3. All right, so you all know pretty much how to make a histogram, and that's just a recap on that. The next step is to describe in words what the probability of x is greater than or equal to 3 means and define that probability. So x being greater than or equal to 3, remember x is your variable that tells you how many siblings you have, so that's the probability of having 3 or more siblings. So 3 or more, we could add up 3, 4, 5, and 6 plus, or we could add up 1 and 2 and subtract those from 26. That's probably the easiest thing to do here. So 2 plus 6 is 8. 26 minus 8 is 18 out of 26 would be your probability of having 3 or more siblings. The next question says, describe in words what probability of x is greater than 3 means. Strictly greater than means that you would not be including 3, so that's the probability of having more than 3 siblings. And that would be, we could just add up anything more than 3. So 5 plus 4 plus 2, that's 9, 10, 11. That's 11 out of 26. Finding the average of these x values. If we were to find the average of the x values, we could add 1 plus 2 plus 3 plus 4 plus 5 plus 6. And then we could divide by 6, and that would equal 3.5. However, there's a little bit of a problem with this average because it doesn't account for the probability of getting that number of siblings in our class, or our fake class, I guess you could say. So instead, we need to create an average that would better represent that. So your answer for this question should be no. Because, for example, three siblings, there are more people in this class with 3 siblings. 3 should have a larger impact. And how we're going to do this is we're going to take each variable number and we are going to multiply it by its specific probability. So we're going to, I'm going to show you what we're going to do here. For 1, there was 2 out of 26 with 1 sibling. We're going to multiply that by 1 plus. For 2, let's scroll back up. There was 6 out of 26 with 2 siblings. So 6 out of 26. So we're going to take each respective probability and multiply it by the number that it's worth, let's say. So 3 times 7 out of 26 plus 4 times 5 out of 26 I'm going to go down to the next page because I'm kind of running out of room, plus 5 times, there were 4 out of 26, plus 6 times 2 out of 26. And once you multiply all of those together, you're going to add them, and then we get a value of 3.346. And if you're wondering, basically there's a formula that goes with it, that the mean equals the sum of all your xi values times their probabilities, which times would be times pi. So I'm gonna put a bubble around that. This specific formula right here that I just circled, that specific formula is on your formula sheet. So that's nothing you have to memorize. You just have to know what the sum sign means, and what xi means each x value, pi means each probability that goes along with it. So very quickly now, let's just talk about some main ideas of this lesson. So I'm going to scroll to here, and I'm going to zoom in a little bit more. And I'm going to write out some important ideas that you guys ideally need to know. So the first thing is that we're talking about discrete variables in this lesson. And they take a fixed set of set of values. And there's no gaps in between. Or I'm sorry. There are gaps in between. So meaning like you cannot have 2.5 siblings. So there would be a gap in between those numbers. Continuous, so I'm going to switch my pen color up. Continuous variables can take any value on an interval. So a way to determine basically the difference between these is, like, you can think to yourself, continuous random variables are able to be decimals, whereas discrete aren't. So if you can't really have a shoe size of like 9.287 or something like that. You can have like a decimal value for the amount of gas you can put in your car. So 16.48756 gallons. So that would be a continuous variable, whereas shoe size would be a discrete variable. So points you could score in a lacrosse game, discrete variable, because you can't score a portion of a point, and so on. Continuous variable could be how fast you could run the mile, which you could get a decimal variation of that. So discrete are typically whole numbers, and you would have gaps in between those numbers. Continuous variables can take any value on an interval. The most important part of this lesson is actually finding mean or expected value. So let me write that formula down again. And once again, that is on your formula sheet, and that's the sum of all your x values times